Today, we're going to pull back the curtain on this secret, high-speed conversation that's happening, like right now, between your phone and the network to keep you connected. Okay, so let's just dive right in by talking about the core problem that, let's be honest, every single one of us with a mobile device deals with. Oh, you know you have. We've all been there, right? It's that universal, just infuriating moment of frustration when your digital world grinds to a halt. But what is actually going on behind the scenes? Well, getting a stable signal isn't as simple as just being close to a cell tower. Not at all. It's actually a massive engineering challenge. I mean, think about it. Your signal has to fight interference from every other device out there. It has to bounce off buildings. It has to navigate this incredibly crowded, invisible world just to get to your phone. So, to fight all that chaos, engineers came up with this really brilliant idea. They figured, hey, if one path for the signal is good, more paths have to be better, right? And this key technology is called MIMO. It stands for multiple input, multiple output. And this isn't some obscure thing. It's a foundational piece of the modern networks we use every day, like LTE and 5G. The whole idea is to use a whole array of antennas to create multiple data streams simultaneously. You know, this is the perfect analogy. A single antenna is basically a single lane road. But with MIMO, you suddenly have this multi-lane superhighway. And that just drastically increases the amount of data, the amount of traffic that can get through at any given time. But, just having more lanes isn't really enough. Can you imagine a highway with zero traffic reports? It would be total chaos. So you need smart traffic control. And that brings us to a really crucial innovation. So the early approach, it was called open loop. Basically, the tower would just send out data using a fixed number of streams, let's say 2, without actually knowing if the phone on the other end could even handle it. It's kind of like shouting into the void and just hoping for the best. So the solution was a total game changer. Engineers created what's called a closed-loop system. And what this does is it turns that one-way shout into a two-way conversation, where your phone is actively participating in managing its own connection. And probably the most important word in that whole conversation is the rank indicator, or RI. It's basically your phone analyzing the signal quality in real time and then reporting back to the tower saying, hey, conditions are awesome out here, send me 2 streams, or, uh-oh, things are getting a little messy, you better back off to 1 stream for now. And with this RI feedback, the whole system becomes truly adaptive. The tower actually listens to your phone's advice and dynamically switches the number of streams from 2 down to 1, back up to 2, maybe even up to 3, to perfectly match whatever the conditions are in that split second. And that makes the connection way, way more robust. Now, this feedback is fantastic, right? But it does create a brand new challenge. See, if your phone is the one making the recommendation, how does it decide what to say? How does it choose the smartest rank indicator? And this is exactly where our source paper comes in. It stages what I like to call a signal bake-off. Researchers basically tested 4 totally different algorithms to see which one could make the absolute best decision for your phone's connection. So each competitor in this bake-off has its own little personality. You've got the overachiever, which is like this pure math idealist. Then there's the optimist, which always goes for maximum speed, but can be, let's say, a bit naive about the real world. Then you've got the realist, which is much more practical. It thinks about the phone's actual hardware. And finally, you have the strategist, which considers everything, the hardware, the data itself, to make the most informed decision possible. So the researchers ran all the simulations, pitting these 4 strategies against each other. And after all that work, which algorithm actually proved to be the smartest? Well, the paper's conclusion is crystal clear. The winner is the mutual information-based scheme. That's our strategist, the Max MI algorithm. It was chosen hands down as the best candidate. And here is the proof. This graph right here shows the performance of all 4 algorithms. So on the vertical axis, you have performance. Just think of it as a mix of speed and reliability. The higher line is on the graph, the better it's doing. And the horizontal axis represents signal quality, going from low on the left to high on the right. Now look right here in this supercritical range between 0 and 6 decibels. See that line with the triangles? That is our winner, Max MI. It consistently outperforms all the others, delivering a pretty significant 6 to 10% performance boost right where it matters most. So why does it win? Well, it all comes down to making a smarter decision about when to switch the number of data streams. These charts here show the exact moment each algorithm decides to make that jump from 1 stream, that's the black bar, to 2 streams, the gray bar. Let's just compare the worst performer, that's Max CP the Optimist, with our winner, Max MI the Strategist. So the Optimist, it gets greedy. It overestimates the signal quality and it jumps to two streams way too early, and that just causes a bunch of errors. But the Strategist, it's patient. It waits until the signal is actually strong enough, and then it makes a much smarter, more reliable switch. Okay, I know this has been a bit of a deep dive, but this whole bake-off has a very, very real impact on your day-to-day experience with your phone. You see, because that winning algorithm is now inside your device, it means you get fewer dropped video calls. It means faster speeds even when you're in a crowded stadium. It means less of that dreaded buffering icon, and just an all-around better, more stable connection. So really, it all comes down to this. Billions and billions of times a day, all over the world, this tiny, intelligent conversation is happening between your phone and the network. And when it's done right, you don't notice it at all. It just works. And that kind of leaves us with a final thought. This is just one of countless hidden conversations happening inside our technology every second. So what other secret negotiations are out there, making our complex digital lives feel so incredibly simple?